The moon orbits Earth in about 28 days. What would be the orbital period of an object whose orbital radius is double that of the moon? So if we apply Kepler's third law to this situation, so T1 squared over R1 cubed is equal to T2 squared over R2 cubed. So T1, we're going to say, is 28 days. So that's the period for the moon, and it's orbiting at a radius of r cubed. Now, T2 squared is what we want to solve for, and we know that R2 is twice the radius of the moon. So, we know that 28 days squared divided by r cubed is equal to T2 squared over 8r cubed. Now, if we multiply both sides by 8r cubed, we would get T2 squared is equal to 8r cubed times 28 days squared over r cubed. R cubes will cancel out, give you a value of 1. You'll be left with T2 squared is equal to 8 times 28 days squared. Now if we take the square root of both sides, this will give us T2 is equal to 28 days times the square root of 8. That's because you can bring the square root to both of the numbers, so 8 and 28 squared. So the square root of 28 squared is 28, and the square root of 8 is simply the square root of 8. If we now carry out and approximate this multiplication, we would find that the period is roughly 79 days. So this would correspond to answer B, 79 days.